What does distribution look like with algebra tiles? Well, we'll first look at a rectangular area, and if we want to show 3 times 2 equals 6, what we can do is show 3 parts one way and 2 parts the other way, and we can see that 3 times 2 gives us an area of 6. When I multiply this out, I know that distribution allows me to say 3 groups of x, or 3x, plus 3 groups of 2 is 6. So we know the answer is going to be 3x plus 6. We can show this with algebra tiles by showing an algebra tile representation. So I'm just going to draw these lines here just to show that the algebra tiles on the outside represent length, and on the inside represent the area, or the actual tiles. So if I have a length of 3, I can show a length of 3 along here with 3 algebra tiles. If I want to show a width of x plus 2, I can show a width of x, so I use one edge length of x, and 2 ones like this. And if you want me, I can shade these in to indicate these are positive, but we'll just assume that we're just dealing with positives here. Okay, so I'll keep these as shaded, so these are indicating a positive tile. Now what's really important is what's happening on the inside here. The answer, or the product, I can see my shape. There is an x tile, there's an x tile, there's an x tile. Okay, that's going to give me 3 areas of x, or 3x. So that's going to be my 3x there. Okay, so this is my 3x. I can also see that there are 6 ones here when I draw in my area based on 3 by 2. So there's my 6 ones, which relate to those 6 ones there. And I can see that my area, my length times width, okay, my length of 3 times the width of x plus 2 gives me an area of algebra tiles of 3x algebra tiles plus 6 ones algebra tiles. So that represents my area. Now, the simplified area model is what we really probably should use, but we also, the algebra tiles, the nice thing about the algebra tiles is it lets us see the individual parts of our multiplication. If I use a simplified area model, the simplified area model looks like this. And we can just say that 3 times x is 3x, 3 times 2 is 6, and we can see, yeah, the 3 individual tiles here can just show up algebraically here. The 6 individual ones can just show up here. What does this look like when I do x times x plus 4? Well, I can do this, distribute into the brackets. X times x is x squared, plus x times 4 is 4x. What does this look like in my algebra tile model? So on the outside, I'm going to show my length and width. So if a length of x, okay, so there's my length of x, and I'm going to have a width of x plus 4. So x plus 4 ones. So 1, 2, 3, 4. And my product is the area inside. So the algebra tiles that represent my product are going to be this x squared tile. So there's my x squared tile. Okay, and then my 4x tiles are going to show up like this. They're going to show up as 4 rectangles. 1, 2, 3, 4. So there's my 4x tiles that's going to show up as algebra tiles. And that's my resulting area. So the length times width, and my product is this area, and the area of these algebra tiles represents my answer. I can do the one here. This is going to be if I have an x tile and times 2x minus 3, well, that's going to look like this. So I have my x tile as my length. Okay, there's my x tile as my length. I have my width is going to be 2x tiles. So it's going to be 2x tiles like this. 1, 2. And then I'm going to have 3 -1 tiles like this. Okay, the resulting area that I'm going to end up with is going to be an x squared tile here. So positive times positive is positive. I have another x squared tile here. Positive times positive is positive. So there's I have 2 x squared tiles. The other part of my area is going to be these rectangular pieces made by -1 times positive is -x. And I have 3 -x tiles. So minus 3x. And I can see that the distribution is going to allow me to get these terms algebraically. X times 2x is 2x squared. X times -3 is minus 3x.